Hello students, welcome to our channel. Today I am going to discuss some previous year question of JEE Advance, basically JEE Advance 2019. So let's start from the first question. Here is the question. As you can see the diagram, a spherical gaseous cloud is given. A spherical gaseous cloud is given whose center is O, and the density is non-uniform of this gaseous cloud. The density is non-uniform and it is varying with distance from the center, and we have to find the number density of the gaseous molecule. So first write the given data. What is the given density is equals to rho 1. Also, the mass of each gaseous particle is given like small m. The mass of each gaseous particle is small m. Mass of each particle is equals to small m. Also, the each particle revolving around the center with a constant kinetic energy K. So the kinetic energy is also given. Kinetic energy of each particle is equals to K. Kinetic energy of each particle is K. Then we have to find the number density as a function of R. That at a particular distance from the center, what is the numbers of gaseous molecule per unit volume? So number density Nr is equals to what? We have to find this. So first of all, we can use this data that kinetic energy of each particle is K. So if the mass of a particle is m and it is moving with a velocity v, then we can write K half m v square must be equals to K. This is my first equation. Half mv square is equals to K. Now, since the particle is rotating in a circular path, so the net gravitational pull on this particle due to the entire gaseous molecules must be providing the necessary centripetal force. So we can also write G, let the entire mass is m. Capital M is the total mass of this sample. Then we can write G m by r square must be equals to mv square by r. This is your equation 2. From equation 1 and 2, from equation 1 and 2, we can write K G m by r square must be equals to 2k by r. 1 r cancelled. So capital M is equals to 2k r divided by g into small m. So now I got the capital M, 2k r by gm as a function of r. So dm, the differential mass of the gas, can be given as 2k dr by gm, sorry, g small m, g into small m. Also dm can be written as 4 pi r square dr into rho as a function of r. 4 pi r square dr is the volume of a thin spherical cell of thickness dr at a distance r, and the volume multiplied by density is the mass. So we can also write the differential mass as this. So from this two we can write ki this implies that 2k dr on gm is equals to 4 pi r square dr into rho. So from here we can find the rho, we can find the rho. So from this line we can write ki rho as a function of r is equals to dr cancel 2k by gm and 4 pi r square. So rho r is the density, that is mass per unit volume. This much mass is there in per unit volume. So now if I divide it by the mass of one molecule or one particle, then it will give the exact number of the particles per unit volume, that is number density. So the number density can be given as rho r by small m, that is k upon twice g m. Sorry, here m is the small one. Small m. Twice g m square r square into pi. So this is the exact answer. Your number density is k upon twice gm square pi square, sorry, r square pi. So this is the number density as a function of r. So this is the exact number density as a function of r. So this question solved. Now next, question number 2. In this question, a metal rod is contained in an insulated box and it is connected through a wire insulated box, and this is connected with a rod and connected with a rod. The wire is providing a constant power P to the rod. Wire is providing a constant power P to the metal rod. This is the situation, and if temperature varies, if temperature varies as T, as a function of T at any time T is equals to T naught into 1 plus beta T to the power 1 by 4. Then we have to find the heat capacity of this rod. We have to find the heat capacity. Heat capacity, capital S, is equals to 1. It is heat capacity, not the specific heat capacity. So it is the capital S. Capital S stands for heat capacity. So first thing is that if P is the power, means P joule heat is produced per second, means the wire is supplying a heat energy equals to P joule per second. So in a small time dt, it will supply a heat amount equals to P dt. And if S is the heat capacity of the body, and during this time dt, suppose during this small time dt, its temperature changes by capital S, capital Y, small differential in temperature dt. So it must be equals to S into dt, because S is the amount of heat required to raise the temperature of entire rod by 1 degree C. So if S amount of S joule heat is required to raise the temperature by 1 degree C, then to raise the temperature by dt degree, the amount of heat must be equals to S dt. So this is the heat supplied and this is the heat received. So this must be equals to this. That is, S must be equals to P dt by dt, or S must be equals to P divided by dt by dt. That is the power supplied divided by the temperature gradient. So I have the function of temperature, so no problem, easily I can find its gradient. I can differentiate it with respect to time. So finding the temperature gradient, dt by dt is equals to T naught into beta by 4 T to the power minus 3 by 4. This is the temperature gradient. That is S is equals to P upon beta T naught 4 and T to the power 3 by 4. We can write like this. So it involves time which is unknown and answer must not be in terms of unknown. So we will try to find T to the power 3 by 4. So this is my equation 1. As T is equals to T naught into 1 plus beta into T to the power 1 by 4. Therefore, T to the power 1 by 4 can be written as T divided by T0 minus 1 whole divided by beta. That is T to the power 1 by 4 is equals to T minus T naught by beta T naught. So T to the power 3 by 4 is equals to T minus T naught by beta T naught whole cube. Now substituting this value in equation 1. Just we will do what? We will substitute this value in equation 1 and simply I will get the value of S. So the final step, S is equals to 4P by beta T naught into T minus T naught upon beta T naught its whole cube. So finally we got S as 4P T minus T naught its whole cube upon beta 4 T naught 4. So this is the final answer. So in this lecture, in this video, only up to this. In the next video, we will discuss latter question also. Thank you very much.